Hey everybody. Today we are going to solve some systems, linear equations, and do some applications with that. Specifically, what's different from 6.2 that is from 6.1 is that we're going to focus on three variables, okay? So we have sort of a ax plus by plus cz equals d. A, B, C, and D are constants, okay? And at least one of them is not a non-zero. So let's just talk in general about what we might see when it comes to this, okay? So just as equations involving variables x and y describes graphs of one-dimensional lines and curves in a two-dimensional plane. Equations involving x, y, and z describes objects on surfaces in a three-dimensional space. Okay, so linear equations represent planes for the 3D space. Okay, we learned some of this vocab before. Oh, it's not on here yet. But what we're going to do is we're going to go over the ways we should go about solving systems of linear equations using three variables and three equations. And we're also going to talk about the vocabulary like we did in 6.1 with being inconsistent, consistent, so on and so on. And I'm going to show you down below, you can see there's diagrams of how these planes can look. So first, let's look at the steps we need to be taking in each of our problems. We want to target one of the three variables to eliminate, okay? Now, eliminate the target variable from one pair of equations. So we always, just like in 6.1, we want to say which one's easier to eliminate, right? So you're going to take two out of the three equations to be able to eliminate that variable, okay? Then you're going to eliminate the target variable from the different pair of equations. So let's say the first two and then the second two. So 1 and 2, 2 and 3. You'll see as we go. Then we are able now to solve a system using a 2 by 2, okay? Just like we did in 6.1. And we go back and we substitute in, we solve some more. It's a lot of work. So you might find that I take little pauses in this lesson. Now, of course, for your video, it might not be a pause. It might be me over here, and then next minute I jumped over here. It's because I took a moment to re-wrap my head around things. That might actually give you a moment to pause what we're doing in the lesson and say, wait, did I understand what we just went over before I go on to the next one? Okay. All right, so let's talk about that vocabulary. We say a 3 by 3 system of linear equations is inconsistent when it has no solutions. Okay, now of course, if you look down below, this one right here is our inconsistent one. Right? Those planes, because they're planes, don't touch, they're parallel, right? A system with at least one solution is consistent. A system with a single solution is said to be independent. Okay? While infinitely many would be, of course, consistent, but it would be dependent. Now, which one's which? Well, we are going to actually look at these formattings as we go, okay? So let's go to the next page and we're going to start our first example. Okay, I'm going to do this slow and organized because it is a lot of algebraic work that there are easily ways that we can make mistakes, so be careful. The first thing I'm going to do to make it more organized for myself is I'm actually going to say and label these equations as 1, 2, and 3. So that way when I say take equation 1, you'll know I'm talking about the top one, okay? Now, if we were to look at this, which variable seems very easy to eliminate? Well, I see that we're able to eliminate, sorry for the blurriness here, that it looks like y and z are pretty close when we talked about question or equation 1 and 3. So here's what I'm going to do with 1 and 3. I'm going to take 1 and 3, put them right next to each other to see what I can eliminate, okay? So I get 3x minus y plus z equals 3. And I'm using equation 3, so x minus y plus z equals 5. Now, if we look at this and we say to ourselves, well, if we add, I can see that my y's disappear. Nope, I get to subtract. Sorry, I said that wrong, because when they are the same, you subtract straight down, right? So 3x minus 1x is 2x. But look what happens. These cancel and these cancel. This did way more than I expected it to. So it's great to see that I got rid of 2 variables right away, because when I subtract here, I'm able to solve this and know exactly what x equals. X equals -1. All right, well, if I plug in -1 for my x's here, that doesn't really help me out. I'm actually going to do this though. If you plugged in -1 and then used it as a 2x2, that's great. I'm going to do this another way, just so we get to practicing of grabbing those equations and then plugging in. That's up to you of what you want to do. I'm going to grab, let's see, I'm going to grab 1 and 2. And I think I'm going to eliminate z in this case. So watch this. So 1 and 2. So first I start out with 3x minus y plus z equals 3. And 2x minus 4y plus 3z equals 16. Now, unlike the one before, I can't just add or subtract straight down because I have nothing that's the same or opposite. So what I'm going to do is multiply the first one by 3. Got that z there. So I get 9x minus 3y plus 3z equals, don't forget to multiply by the other side, 9. Okay, this one I'm going to keep the same so I can get rid of the z's. Now, the truth is, guys, yeah, I'm getting rid of the z's, but did I have to? Could I have gotten rid of the y's? Yes. You could do this in any order, and it should still come out to the same solution. If it doesn't, it means you did something incorrect. Okay, these are the same. So again, I'm going to subtract straight down. I get 7x plus y, right? Because -3 minus -4 is a +1. Those cancel. That was the whole point, equals -7. Well, guys, even though we could do more with this, what do we know that x is? We know that x is -1. So let me plug that in. 7 times -1 plus y equals -7. So if I look, -7 plus y equals -7. So y must be 0. I have 2 variables. The way to find the third one is just to plug in and solve. Now, what I said before, shouldn't matter which equation I plug into. No, it shouldn't. So if you want to double check your work, plug it into 2 equations and make sure you come up with the same z, okay? Now, when you also plug in and you're trying to find z, don't take the hardest equation. Find the easiest one. And to me, it's either 1 or 3. I'm just going to take the first one because I like using the top equation a lot. So I'm going to say 3 times -1 minus, well, y is 0, plus z equals 3. So -3 plus z equals 3. So z equals 6. All right, well, when we write our solution, usually we write it in alphabetical order, x, y, z. So my coordinate would be -1, 0, 6. So they all intersect at that point. Okay, it would almost be like your planes, right, at that point. So what does that mean? It means there's a single solution, so it's consistent. And remember, there's two answers for consistent. And because it's only one single, it's independent. Very good. Now is the time if you want to pause the video, go, okay, let me see if I got what we just did. Okay, if not, go on to your next page. Another example. All right, I'm going to label these again, just so as I say equation 1, 2, and 3, you know where I'm getting them from. Remember, the idea is we're going to take two of the equations and try to eliminate a variable. Okay. I might not look at 2 right away. I kind of like 1 and 3 for the fact that I can multiply the top one and then add straight down to get rid of the y. Now, why would I do that? Well, if I do that, that allows me to say whichever answer I got, I can match it up with this one and break it down more. So I'm going to take 1 and 3. Okay, so 2x plus 3y minus z equals 1 with 4x minus 9y plus 2z equals 5. Okay, what did I say before? I said, oh, I'm going to get rid of y here. So my answer, I can match up with equation 2 and then solve for one of those variables. But to do that, I have to multiply the top one here by 3. So I get 6, sorry, I wrote that, 6x plus 9y minus 3z equals 3. And the second one, I'm going to keep the same. So 4x minus 9y plus 2z equals 5. Because they are opposite, I'm going to add straight down. I get 10x minus z equals 8. Okay. Now this allows me to take that one. 10x minus z equals 8. Compare it with our second equation, which is 10x minus z equals 2. This is nice because we have the same x's, right? So we can subtract straight down to find our z's. But what happens? 10x minus 10x is 0. Negative z minus negative z is 0. 8 minus 2 is 6. Wait a second. 0 can't equal 6. Well, if you remember from our old algebra days, when we get a false statement and all of our variables have disappeared, our answer is no solution. And what's the wording that we do for this one? Well, no solution means it's inconsistent. That one wasn't that bad. All right, let's see where we can get here. Let's try again. Well, I'm guessing we're going to do the third type of system, right? So we had consistent, independent, inconsistent. So I bet you this one's going to be consistent, dependent. Okay. Label those again, 1, 2, and 3. All right, what looks like some good stuff to do? Well, I don't know. Let's, it looks like when I did this earlier before, I decided to get rid of the y's to see what happens here. So let me do that. I get 2x, so I'm doing 1 and 2, guys. 2x plus 3y minus 6z equals 1. I'm comparing it with negative 4x minus 6y plus 12z equals negative 2. Means I have to, I'm going to get rid of y, I think. Oh, actually, look, even if I got rid of x's, let's multiply the top by 2. I get 4x plus 6y minus 12z equals 2. You guys notice why I did that? Well, if you look, all of these are opposite. Sorry, I put x instead of y. Which means if I add everything straight down, what do I get? I get 0 equals 0. Okay? So right away, I know this is a true statement. So right away, I'm knowing that this is consistent, dependent. Okay, so what does that mean? That means, did I even spell that right? No. Okay. What does that mean? That means all the other coordinates, or like the x part and the y part, depend on what the z part looks like. So a lot of people, when they do this, is that they will solve for x and y in terms of z. And I will tell you that some schools or some teachers want you to compartmentalize the solution. In other words, they make it so t is involved. I'll show you what z's and then we'll go from there. Okay? All right, so what I'm going to do now is make sure that I can solve for x and y, because it's all going to be dependent on z's. So if I look at my thing again, let me get rid of the x's first, because it looks like I'm able to get rid of the x's with, let's do 2 and 3. So I'm going to look at 2 and 3. Okay. So 2 is negative 4x minus 6y plus 12z equals negative 2. 3 is x plus 2y plus 5z equals 10. So that means if I said I was going to get rid of the x's, I keep my first one the same and multiply my second one by 4. So I'll get 4x plus 8y plus, I'm multiplying by 4, so 20z equals 40. Okay, so if they're opposite, it means I add straight down. So 2y plus 32z equals 38. All right, what am I doing? Remember, I got rid of x, and I'm going to solve now for y, because I'm going to solve for it in terms of z. Okay, so that would give me 2y equals 38 minus 32z, and y equals, so now we have to divide, right? 19 minus 16z. Okay. All right, we can do the same thing again by eliminating y and solving for x, or we can actually substitute y in. And does it matter which equation we substitute into? No, we just know that we're solving for x in terms of z. So I'm going to make it easier on myself. I like dealing with the first equation, but it should not matter. So this was to find y. I want to organize this so you guys can go back. Find y in terms of z. And the next one here, we're going to find x in terms of z. Again, you could do this by eliminating, taking two equations and eliminating, just like we did up here. Or I'm going to give you this other way by substituting in. I'm substituting into the first equation. So I get 2x plus 3. Now, instead of y, we know y is 19 minus 16z minus 6z. Okay? Equals 1. Now I do my normal algebra here that we're so used to. 3 times 19 is 57 minus 48z minus 6z equals 1. Combine like terms, 2x plus 57 minus 54z equals 1. Move everything over. 2x equals 54z minus 56. Divide by 2, we get x is 27z minus 28. Okay. Now remember, I said this is dependent. So the x and y depends on what value you put into z. So how do we write this in a coordinate? Be very careful. This is the more higher level one, so you want to get this down. Well, even though we're still going to go in x, y, z pattern, I actually am going to write these formulas down, or these expressions down. 27z minus 28, comma, because our y is 19 minus 16z, comma, z. So now, because there's infinitely many solutions, it all depends on what z is, I could plug in 3 for z, and then we would have an x, y, z coordinate. I could plug in -5 for z and have an x, y, z coordinate. Like I said, if you see that we turn z's into t's, it's just because we're letting it change. Like if we put in anything for t, this is our x, y, z. I'm going to keep it in z right now. Okay. Again, pause if you need to. I'm going to take a moment, readjust. All right, applications. So, of course, as you can see, we don't have the equations just made for us. We're going to have to read this out and identify where equations are. What I want you then also is to identify just first equation, second, third, okay? So, John received an inheritance of 12,000 that he divided into 3 equal parts. Okay, there is one equation right there. And invested in 3 ways. He invested money market fund paying 3% annual interest. bonds. This is where my husband comes into play, right? Paying 4% annual interest, and mutual funds paying 7% annual interest. John invested 4 more in mutuals than he did in the bonds. Hey, there is our second one. Now, where does our third one come from? Because there was percentages up here, right? We have to worry about that. But we just know that that's how the interest is. But if you read down here, he earned 670 in interest. So we have to use those, and that is our third equation, okay? Now, we need to label our X, Y, and Z. Could you label them all over the place? Yes, you could. So I'm going to say my X is the money market. And remember, we have Y, and the second one is our bonds. I'll do. And Z, I'll put as our funds. You want to be able to label which one's which, guys, because one, we have different interest rates. Two, your partner or your classmate who you go over things with, you might have different X and Y's, or you mean them, you switch them differently, and then you think that you're wrong, but you might be right. So label your variables first. Now let's make up our equations. So here we go, that John received in here is he has $12,000 and he divided it into three equal investment ways, okay? So, or not equal, but invested it in 3 ways, right? So in other words, whatever he invested in the money, in the bonds, and in the funds, they all add up to $12,000. That is equation 1. Equation 2, you have 4,000 more in mutual funds than he did in the bonds. Be careful about this. 4 more in funds. That means what we're doing is we're taking the funds and saying it's equal to the bonds plus 4,000. This is the tricky one, okay? Make sure you go back and you say 4 more mutual funds. That means I should have, the mutual funds should be greater than the bonds, okay? Second, or third question here, he earned 670. So he earned 670 through interest. Well, how do we get interest? We multiply the interest rate by the amount we put in. So the money marketing was 3%. So 3% of X plus 4% of Y plus 7% of Z. Okay, so all of our interests equal $670. Now, it's great that we set up this, but we want to rearrange it so it works out to one of those problems that we were doing earlier that didn't have any application. I just gave you random numbers, right? So the first one looks pretty good. So let's keep the first one as X plus Y plus Z equals 12,000. Okay, let's move that Y over so we have Z minus Y. Now be careful, you want to keep it in the correct order so they all line up. So negative Y plus Z equals 4,000. And I don't know about you, but those decimals look kind of icky. So why don't we multiply everything, all of this, by 100? And that way we're not looking at the decimals. So I get 3x, oh, let's line it up, plus 4y plus 7z equals, and I have to multiply 100 on the other side, so I get 67 I'm teaching you more and more not to use a pen. 67,000. Okay, now this looks like one of the problems we had before. So now let's start going and seeing what we can get rid of. Well, I like number 1 and number 3 because maybe I can get rid of the x's. I like getting rid of x's first for some reason, especially since I see I don't have an x here. So that's going to help me out with getting y or z depending on what I want to do after that. All right, so I'm going to take 1 and 3. So I get x plus y plus z equals 12,000. And I'm taking 3x plus 4y plus 7z equals 67,000. Well, it looks if my plan was to get rid of x, I have to multiply the first one by 3. So I get 3x plus 3y plus 3z. Don't forget to multiply. Ooh. Okay. Don't forget to multiply the other answer there, which would be 3 times that would be 36,000. This one stays the same. 4y plus 7z equals 67,000. Okay, they are the same. So what am I going to do? I'm going to subtract straight down. So I get negative y minus 4z equals negative 31,000. Okay, that looks great. Now what can we do with this? Well, we can take this equation right here. So I'm going to rewrite it. Negative y minus 4z equals negative, oh, sorry guys. I just realized you can do that. Negative 31,000, and I'm going to compare it, right, to the second equation we had. So with number 2, we're doing this one, right? So I know where my work is on my paper. With number 2, number 2 was 7y plus z equals 4,000. Sorry guys, it's lunchtime. And then as I can see now, even though I didn't plan it, I see that I don't have to do any manipulation. If I subtract straight down, I can get rid of my y's. I end up getting negative 5z equals negative 35,000. So I get z equals 7,000. Okay, so that means he's investing, right away I know, he's investing $7,000 into mutual funds. All right, now what can I do with that? Well, guys, the good thing is if you look at our equation number 2, if we have z, can't we just substitute in and find out what y is? So let's do that. So we get negative y plus 7,000, I'm using this, equals 4,000. So y equals, when I solve, y equals 3,000. Okay, that means he's investing 3,000 in bonds. Because y was my bonds. All right, well, if we have z and y, what can we do next? Well, the easiest one to plug into is that first equation. So x plus 3,000 plus 7,000 equals 12,000. So what do we end up with, guys? X equals 2,000. So he's putting 2,000 in the money market. There we go. And again, we can check our answers by plugging in at any time, and they should all work to be a solution. Awesome. One more question, guys, and then we are done. This one has us working backwards a little bit, or not really backwards, but it's taking a different application. So what we're going to do is find a quadratic function that passes through the points 1, 6, negative 1, 10, and 2, 3. All right, so what am I looking at right here? I'm looking at coordinate pairs. In coordinate pairs, we have x, comma, y. Okay, so those are x values and y values. Remember, that's also input output. When I input an x, I get an output, which is that y. Okay, next, vocabulary there. It says quadratic function. Well, what is our general form of a quadratic function? Well, that would be the form of ax squared plus bx plus c. But don't forget, a cannot be 0. Because if a was 0, we no longer have a quadratic, we have a linear. So a cannot be 0. Well, look at what we have, guys. F of x is usually what value? It's the y value, it's our output. So we can create 3 equations that allow us to do systems. So when x is 1, we get a plus b plus c equals 6. Again, 1 squared is 1, 1 times a is a. 1 times b is b. Okay, let's do the next one. When I plug in negative 1 for x, I still get a. I get negative b this time, plus c equals, and the output for that is 10. Again, how I'm getting this is plugging in negative 1 for x. That gives me my a minus b plus c. And of course, the value of that should equal 10. Let's do one more here. So when I plug in 2, well, 2 squared is 4, so I get 4a, plus plug in 2, I get 2b, plus c. And when I get all that, I get 13. So there are my 3 equations. Oh, let's see what we can do. Well, a variable that looks very easy to solve for right now, I like adding more than subtraction. I don't know about you. But it looks like if I add the first 2, I can get rid of b. So let me do that on the side. So 1 and 2. So you keep note of what you're doing. So I have a plus b plus c equals 6. A minus b plus c equals 10. Add straight down. I get 2a plus 2c equals 16. Okay, that's great. But as you can see, I still have 3 variables up there. So what I'm going to have to do is take 2 more and eliminate b again. So now that I have a 2 by 2 system that I can work out, okay? So now let me just take 2 and 3. Now, could you've taken 1 and 3? That's fine. Okay, so 2 is a minus b plus c equals 10. I have 4a plus 2b plus c equals 13. Again, what variable do I need to get rid of? I need to get rid of b because I want it to match up here so I can solve for a or c. So I need to multiply the top one by 2. 2a minus 2b plus 2c equals 20. Keep the bottom one the same. 4a plus 2b plus c equals 13. Looks like we're going to add straight down again. We get 6a plus 3c equals 33. Now I'm able to use these two to help me solve for A or C. So I'm looking at 2A plus 2C equals 16. I'm looking at 6A plus 3C equals 33. Now, if you look at this, guys, now we're going to analyze which variable can we get rid of the easiest. Well, if I get rid of C, I would have to multiply the top and the bottom by numbers, where if I get rid of A, I can just multiply the top. Okay, so I'm going to multiply the top by 3. I get 6A plus 6C equals 48. Bottom one, keep them the same. Okay, these are the same, so I'm going to subtract straight down. I get 3C equals 15. So C equals 5. Now, here's the other thing. If you trust yourself, if you trust everything you've done, why do more of this? All of these are just arrangements. So can't I just plug this into one of these equations and solve for A? Yes, but make sure you double check your work at the very end and make sure that coordinate you come out with works for everything, okay? So if I do that, let me plug it in here. So I get 6A plus 3 times 5 equals 33, and I solve 6A plus 15 equals 33. 6A equals 18. So A equals 3. Now I can go back all the way up back to that first equation, because that one's the easiest, right? I would get 3 plus B plus 5 equals 6. B plus 8 equals 6. So B equals -2. Oops, I'm doing work and I'm not showing you. So that's me plugging into that first equation, okay? Now, what does that mean? Well, that means we have our A, our B, and our C. So our function is, our A was the value of 3, so 3x squared. B is -2x, and then C is 5. And there is our quadratic function. Again, if you wanted to check, we could even check with this. So does 3 minus -2 plus 5, does that equal 10? Yes, it does. Is 4 times 3 plus 2 times -2 plus 5, does that equal 13? Say 12 minus 4 plus 5, 13, check. All done, guys. Take your time, organize your work.